Welcome back to our lecture series on automated machine learning. Now we're diving into AutoML in the age of foundation models. And of course, we're starting first with a big picture before we go into the details. So let's see what we have. First of all, large language models are maybe the most well-known kind of foundation models are out there. And although I fully agree that it's great that we can now chat in natural language with these kind of models, I think the real clue is something else. If you're thinking about traditional machine learning, how it was done, I don't know, 3, 4, or 5 years ago, it was always like there's one kind of data set which led to one kind of model, and then hopefully the task was solved. It was really like for each task and data set, we build one model. And that goes quite a bit also in the mindset of automated machine learning. But in practice, we can see that we don't have to do it maybe in the same way as we did before, over and over again. But these days, we're talking about foundation models by feeding in a massive amount of data, maybe with different kind of data modalities, definitely with different kind of tasks in mind. And then we train these models. And the nice thing is why we call them foundation models is they allow us to do many different kind of things, Q&A, translation, generation of new images, whatsoever, based on given inputs, right? So we don't need to start to train them from scratch to do now a different task. They can do many tasks for us. Maybe we would like to fine tune these kind of foundation models, but that's in comparison to what we did before, much cheaper because we can start from these massive foundation models and don't have to do it from scratch. What does that mean now for AutoML? Why are foundation models a challenge actually for automated machine learning? Here we can see it a bit like, now we have these kind of things in mind, like meta learning, HPO and NAS for automated machine learning, and of course pipelines and all of that. Now if you're thinking in terms of foundation models, so there's often a pre-training phase involved. That's the crazy expensive phase at the very beginning. If we're really thinking about state-of-the-art large language model agentic system, that costs hundreds of millions of dollars. So super crazy expensive, can't afford much of them. And objective are something like basic language understanding, generations of skills. We really update all weights of a network, and we have ample actually of different kind of hyperparameters being involved. Then there's already the fine-tuning phase, and fine-tuning comes then also with different specific parts. For example, the alignment. So we now try to train or fine-tune our model in a way that it's so helpful, that it's honest, it's harmless. We maybe have now involved something like reinforcement learning. So we have a policy net now we have to think about in terms of reinforcement, in terms of automated machine learning. We have something like state representation and all of that. And this related to that part, of course, everything comes with reinforcement learning is being involved, or what makes reinforcement learning hard actually for automated machine learning. Of course, we have to think about network architecture, but also about exploration behavior or pre-processing of feedback from human sources, right? So a lot of noise, conflicts actually in our data and all of that. If we then, as next step, maybe doing task-specific supervised fine-tuning, maybe we would like to make it more factual or adding in-context abilities. Now we're adapting more layers to it. Or a subset of these layers. So we müssen weights select. So we have to select weights. We have to adapt the placement and all of these kind of things. And then we go over to instruction tuning as one further kind of fine tuning. Again, it's about factual knowledge. It's about adapting things and so on. But it's again not now these task-specific supervised learning, but instruction tuning that it behaves more or less based on instruction, for example, like a chatbot. At inference, we have further problems more, right? We have to care about inference cost, utility. There are different kind of prompts we could now optimize, or generation head, network connections, all of that. And again, coming with many different kind of parameters. On the most well-known is maybe temperature in that respect, how free you are sampling, for example, from your distribution of what is the next token. Good. Coming to the next slide. If you have that in mind, you can already imagine why it's quite hard for AutoML to be applied to these kind of foundation models if we really do it in that full model perspective. First of all, as I mentioned already, pre-training is super expensive. Basically, if you would like to train more than 10 of these, even on smaller fidelities or approximation of the full scale, it's I believe, not feasible in most cases. Of course, there are smaller foundation models where you can do a little bit more than 10, but it's often really like these kind of scale, I don't know, 5 to 10, maybe 20, but you have to be super efficient in deciding what are architectures, what are hyperparameters. You can't afford many of these. Then we have seen that we combined now several learning paradigms, right? So pre-training was self-supervised. Then we had with the alignment tuning, reinforcement learning involved. We had later supervised learning involved. So we have all of these being part and include together in different kind of stages. Each of them comes with their own metrics, design spaces, configuration spaces. And one can imagine that there are many interactions between these kind of stages. But often what we're doing so far is actually tune them independently because we can't afford to tune them jointly. Nevertheless, that would be one of the holy grails we're aiming for. And foundation methods make use of several data modalities, right? We have seen as the classical one, of course, text, but there could be also images, videos. People talk more about tables. And each of them comes with their own data preprocessing, with their own backbone models. So combining them simply makes the entire design space AutoML could cover in an exploding fashion, right? That's tremendous what we could here actually combine and tune. On the other hand, what are the opportunities thanks to foundation models? So let's take the other perspective. Can we now make use of foundation models for AutoML? Certainly, foundation models can be trained for AutoML tasks. For example, people showed that AutoML or foundation models for AutoML can be used in a way that we, for example, generate data preprocessing and so on, so that we more and more now leveraging all these potentials, especially large language models and coding agents. LLMs are the most powerful meta models to date and allowing access to prior knowledge from all kinds of sources, books, papers, tutorials, code, etc. pp. Since they're trained on all of them, we can also access to a certain degree, as always, but we can access these kind of knowledge with different kind of prompts and so on, which makes it super useful actually to combine ideas, to warm start AutoML, to find very efficient new solutions for new tasks. LLMs can also more easily, at least, operate in unbounded spaces, in contrast to the typical bounded spaces, for example, of Bayesian optimization for HBO, which potentially require expert knowledge to define the space before using AutoML text. So that goes to sense away, right? If you can say, please, LLM, do the job for me. Agentic AI, please come up with code and play around with that, evolve that, try new things. We don't necessarily have to define what are the bounds for our configuration space anymore, which makes it much more powerful. LLMs, and in the same way agentic systems, allow for generation of code, as I already said. And that increases, of course, the scope of AutoML down to the code level, makes many more things possible. That's the summary, most important things from this video. It's exciting to see how AutoML flourishes and faces new challenges at the same time. So we are, I would say, in a golden age of AutoML where we have far more possibilities, but at the same time, also many new challenges where we don't yet know the answer. AutoML is going to be redefined from narrow tasks to broader, more powerful capabilities, and we've seen more and more prototype and papers coming out of that. And we're going quite a bit away from that kind of mindset, okay, we tune a few hyperparameters, but more to a mindset, let's try to define entire workflows for machine learning with the possibilities of foundation models. We will focus actually more in these upcoming videos on the possibilities for AutoML enabled by foundation models and LLMs and agentic systems, of course. And we discuss less the part on how to make AutoML available for foundation models, because at the end of the day, that's quite a bit, as you have hopefully seen in other videos already. That's all about making AutoML efficient, with warm starting, with fidelities and all of that. So I think you should already have all the ingredients for applying AutoML to foundation models. But now we will focus more on the new exciting part about what can we do with foundations models for AutoML. With that, I hope to see you in the upcoming videos.